What is up, fellas? All right. So, today, I am making a mounting tray for my little quad. I'm adding GPS to it, but there's really no convenient spot to put the little GPS module. And let's see. Oh. So the GPS module is this itty bitty thing. It's like 20 millimeters square, and there's just no good place to stick it on the quad where it wouldn't get messed up by like the battery or something like that. So I'm going to make a little tray that will get epoxied to this piece, and this is where the antenna goes on the back. So it'll go down here and then stick out a little bit, and this thing will get mounted like right there, like that, on the back of the quad, and hopefully it'll work. So we're gonna jump on into Fusion 360 to do some design, and I'll have my trusty calipers here to make sure that everything is dimensioned properly. So let's go ahead and jump into there and start designing away. So the first thing that I'm going to be doing is just measuring out this little GPS module. Like I said, it's right about 20. It's 20 degree or 20 millimeters. Let's see, that'd be 20 millimeters wide. Yeah, it's right at 20 millimeters on all sides. So the first thing that I'm going to do is I'm going to make a box that is about 20 by 20. I'm going to make it a little bit longer. Colorado's burning on fire. Hope you're all right, man. Stay out of that. Stay away from the fire. That's bad. So we're going to do a center rectangle right here on the origin, and we're going to make it 20. We're going to make it 20.1 just to add a little tolerance. God damn it. There we go. Ah, that's not what I wanted. I want to edit that part. Dang it. Let's just delete that. So we'll do another center rectangle, 20.1 tab. No. And now we'll hit enter. So that'll be kind of the start of our little project. And so that's the first part of it, the first kind of square that we're going to use. And then we're going to do something called an offset. We're going to take that whole thing and do another square right outside of it. Beep, 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 beep. So we should be able to take those 4 lines and do I thought we could do something. Cool. Well, we'll just do a whole new center rectangle, because I also want a standoff in the center that is about 0.75 millimeters away from that. So, and we also want the surrounding area to be 2 millimeters. So we have like a 2 millimeter wall that surrounds the GPS module. So we're going to do another center rectangle that is 22.1. All right, so that's going to give us our external walls. And then right on the inside, we want about a 0.75 millimeter standoff that the circuit board is going to sit on that standoff on all sides, and that is going to lift the circuit board up off of the base of the mount because we have little, and you guys may be able to see that there's little plugs there that we need some clearance for on the bottom. I don't want it sitting on those plugs. I want it raised above them by just a little bit. So that lip that it's going to rest on those four sides is going to be about 0.75 millimeters thick. And that's where it would come in really handy if I could remember how to do the offsets. I don't remember how to do that. I should probably, watch a video of someone doing this who's smarter than I am. There it is. But that's not what I wanted to do an offset of. I want to do an offset of that. No. Oh, I get it. Okay. So we want to go in by negative 0.75. Awesome. And also that one is a little messed up. So we're just going to delete that whole guy right there. And we should probably delete all the dimensions that are associated with it. Okay, and we're going to do another offset of that outside that is 2 millimeters instead of 1. We'll go 2 millimeter offset. Perfect. All right, so now we've got our base sketch. And what we're going to do is we're going to go ahead and finish that sketch. And we're going to start extruding some things, right? So we want this whole thing like all of these areas to be 2 millimeters thick on the bottom, on the base. So we're going to extrude it up by 2 millimeters. Come on, thing. Do what I want. Awesome. Oh, you know what? I just kind of messed up a little bit. Not really. I probably should have done that first, but this will still work. We can show that sketch again, and we're going to draw everything else up from the bottom, and that's fine. Actually, we could still do it from the top. So instead of cut, we're going to join, and we're going to hit OK. So that gives us our initial tray. Now we may need to come up from there a little higher, just based on the height of the circuit board that I'm working with. And that is, let's see, 4.35. We're actually going to make it just the same height as the rest, which is 10.73. So we'll make it 10.75 tall. So this has like a little bit of a protective shroud around it. So if it gets knocked by anything, it hopefully won't destroy it. So we're going to just raise that. We'll go ahead and make it 11. So we're going to add 9 more millimeters to the extrusion here. All right, and that's going to make the box a little bigger than it used to be, and that's okay. That's exactly what we are looking for, is a little box for this thing to sit in. Now, the next thing that we want to do is we want to raise that offset that will allow this thing to be sitting a little higher, or not sitting directly on those the plugs. There's little connectors on the front and the back, and I don't want it sitting directly on those connectors. So we are going to make some small standoffs that are just slightly taller than the plugs. And the plugs look like they're about 3.1 millimeters. So I want those standoffs to be about 3.5 millimeters, which will leave us about a 0.5 millimeter gap between the plug and the bottom of this little case that thing is going to sit in. And you know, we're kind of extruding from the bottom, which is a little weird. I just kind of messed it up. I probably should have made the initial base square first and then extruded from there, but that's not what I did. So we're going to go ahead and tell it to extrude. Now this is already, 0.75 millimeters. So it's the right thickness, and as we extrude that up, so that's our initial 2 millimeters, and we need to go another 3.5. So we're going to make it 5.5. Oh, oops. So we want to delete that last extrusion. I accidentally did cut instead of join. So we're going to do that again. 5.5. Join. Okay. All right. Now what we'll see is around the perimeter of the box, you can see that there's a small ledge, and that small ledge should be 3.5 millimeters tall. And what we can do is if we want to check those dimensions, we can do inspect. We can measure from here to here, and we can see the dimension in there. It has right over here that it's 3.5 millimeters. We can see also here the distance is 3.5 millimeters. So we did extrude it the right height. It is 3.5 millimeters tall. That standoff, and that's going to give us the room that we need to allow the circuit board to rest on that standoff instead of, the bottom just sitting right on the bottom of that base. Now, the next part that we need to figure out is we do have a plug that goes into the bottom. So where this thing is going to sit down in that case, I need to have an opening for that plug. Now this is perfectly square, so I can have that opening basically anywhere that I want, and I need to have that on both sides. One will just be a cutaway, and the other will be we're just going to remove that area. We can go ahead and close that measurement. The other one will be removing, hold on, let me get this oriented the way I want it. And we can turn off that sketch because I don't need that anymore. So basically what we're doing is we're going to cut a hole out of the back of this thing. And on one side, and on the other side, we're just going to cut a groove into this standoff where it can sit down in there properly. So we're going to start on the area, we want that to be the back of the box. So we're going to start a sketch on this surface of the outside of the box. And the first thing we're going to do is we're going to draw a construction triangle that is 2 millimeters tall and the entire width of the box. And the reason we're doing that is because that is going to tell us where the base is. So 2 and 24.10 is correct. So now, everything above that line is above the actual floor of the case, right? So we're making like a little case here. So what I want to do from here, we also want to make another construction triangle that is 3.5 millimeters tall. All right, and what that's going to do is it's going to tell us where the top of that ledge is. Now, what we want is we want a hole that's going to get created right in this area where the plug for the GPS module can go into that hole with it sitting down into the case. So we want to measure, let's see, this is the back of the case. We want to measure how far it is from the side of the plug. That's 5.88. We'll do 5 millimeters. It looks like we can just do 5 millimeters on both sides. And that's going to give us the clearance that we need for that plug. So we're going to do 2 more of these. And these are just, the construction triangles are more like reference points, right? So that's 13, and we'll do 5 millimeters. And we'll draw one more that is 13 by 5 millimeters. All right, and we're going to go we can go all the way to the floor, and we're going to go 1 millimeter above to make sure that we've got plenty of clearance there, between those. So this next one that we'll draw is not going to be a construction because it's not for reference. This is actually going to be a cutting tool that we're going to use. So that's 3.5. So we'll make it 14.1. And let's see what the actual measurement is there, because I know that I'm giving myself some extra room. Yeah, the thing is only 8. I know what it is. The sides are also 2 millimeters. So we're gonna do so that was 5. We're gonna create a couple of more construction triangles because we need to have all of the walls correct on here that we can use as references. So that gives us all of our walls, and now we're going to do another one that is 5 millimeters. Offsets. And now that should give us the right size that we need. So now we can do a standard rectangle. Let's escape from there. We'll start it from the other side. We'll start it from the bottom. So as we extend it, it'll go up. And we're gonna make it 4 millimeters tall, about a 0.5 millimeter taller than where that sidewall is. And what we're going to do is a little bit of cheating because I need that cut out on both sides. So we're going to finish up the sketch here. We're going to take that square and we're going to use it as a cutting tool to cut a hole through the entire thing. All right. So we're going to extrude that and hit OK. So that gives us the hole that we need on the back. We don't actually need a hole on the front, but we do need that relief, right? And we need the relief to be immediately across. So what we're going to do is a little bit of cheating. We're going to take that surface right there, since we didn't need to cut a hole all the way through it, but it was just more convenient to be able to get that piece in there and cut away that backside. So we're just going to extrude that back down 3.5 millimeters or 4 millimeters and close that gap back up and join it. So we'll see now on the inside we've got a hole on the back, as you can see, and on the front side we've got that little recess in there where that standoff is. So now where the plugs are on the GPS unit, it will fit down into where those standoffs are and will allow us to have that seated with the edges of the circuit board resting on that little shelf that's inside the box, and the plugs are not going to interfere with anything. And on the back side of the box here, we've got our hole so the plug can go in there and mate into the socket that's on this side of the circuit board. So that is pretty much all that we need to do for our box. Now, the next part that we need to do is we're going to take and let's see, probably the easiest way to do this, and we'll go back to the full screen view here. Give me just a second. All right. So this thing is kind of polarized. We're going to go back here to this because it'll be helpful for you to see how this is made. This is a mounting bracket for the antennas. All right, so I've got my crossfire antenna that goes in that little area, and it just shoots across the back of the quad. And I've got this, and this is where the video antenna mounts, right? And what I'm going to do is this box that I'm building, I want to epoxy onto this flat spot right here, and then go straight out, and this GPS unit is going to sit about like that, right? So we know about where we want that to sit. So what I'm going to do is I'm going to create a new plane that is on that surface, right? So I don't want to make a sketch that's limited to this surface only. I need the entire plane to be on that surface so I can make stuff outside of the sketch, if that makes sense. Yep, and that is the back, that is the front. Right, so I need to make a, let's see. Doo-doo-doo. We're just going to do an offset plane here, but it's not going to actually have an offset. We're going to leave it at 0. So it's going to be right on the edge there. And what that's going to allow us to do is create some a drawing that is on that plane, right? And what we're going to do is let's see, we're going to create a sketch on that new plane that we created. Yep, so we can, make shapes anywhere. I believe we can do that. Yep, we can. So we'll remove that little piece. And what we're going to do is we're going to create another set of construction lines here on this sketch because I want to use those as a reference. Right, so again, I've got 2 millimeters is my base, and we'll run that all the way out to the edge there. I think that's 24.1, 24, my God. All right. And then from there, we need to go up by 3.5. So we'll make another construction triangle that is 3.5. Sorry, my computer, my keyboard's acting up. So I keep having to input these measurements over and over and over again. I guess it's time to invest in a new keyboard. All right. So now we have our second set of construction rectangles. And what I'm going to do is I'm going to create a 40-degree slope that the box can mount to. Oh, shit. I'm not showing the screen. Well, that was crappy of me. Hi. All right. So the way I want this to sit is just like this. So I want the start of the slope to start where that offset goes up, and I want that slope to also be 2 millimeters. So what I'm going to do is, starting from this point, I'm going to create a 45-degree basically rectangle that goes up, and we're going to go from there. So the way that I'm going to do this is I'm going to create what's called a 3-point rectangle, which allows me to select let's see, we don't want that to be construction. We want that to be an actual 3-point rectangle. Now this should be telling me roughly what the angle is too. So that is trash. So the first thing we'll do is we'll just create a construction line at the right angle to make sure that we get all that right. So let's see, that's 180. We want that to be 140. And we can just have it going out to, you know, generally anywhere. But we want that to be a 40-degree angle, so we can see that arc on the top there is at 140 now. And that's going to give us that 40-degree angle that we need. And we'll do another one there. Okay. And you'll see why we did that one here in just a second. Now, the next thing that we'll go back now to creating that 3-point rectangle. The 3-point rectangle, we want that 3-point rectangle to be we don't want it to interfere with the SMA plug of the antenna. So we're going to make it about 10 millimeters in, you know, it's going to come about 10 millimeters up, right? So we'll draw the first point here, and then we want that to be 10. All right, and we want it to be, let's call it 2 millimeters thick. Uh-oh. And that's okay. We'll be able to change this. I don't want all of that. We will change those to actual build lines. And we're going to draw another line that goes from here straight down. And I think, yeah, if we hold, well, we're just going to eyeball it. Actually, we'll just run a little further through it. That works too. Why does that keep doing construction lines? I want that to be an actual line too. All right. So what we did is we made like this little shelf. Now I'm going to go ahead and finish that sketch. So now we've got this funky looking shape here. And what we're going to do is, I don't believe that shape extrudes into the body at all. But we're going to basically run that shape all the way through the original body. So we're going to extrude that this way. 24.1. Negative 24.1. And we're going to tell it to join and hit OK. And now you can see we've got a little 40-degree shelf there that's going to be part of the print. And what we're going to do here to add some strength to that shelf is right up here. We're going to do another sketch and create a rectangle, 2-point rectangle that is 2 millimeters, and it's going to stretch the entire length. And we're going to finish that, and we're going to extrude that out this way. Boop, 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 boop. And that should be plenty. And we're going to hit join and join those together. And let's see. We're going to get rid of that weird looking thing up here. So right up here where we got that funky little tooth looking thing that sticks up, we're going to get rid of that. So we're going to do another sketch here on that side. We're just going to draw a simple line that goes from here to here. We'll finish that sketch. We'll highlight that. Whoop, whoop. And we will do an extrusion across the whole thing and do a cut. And it cuts that right off. So now you can see that I've got, you know, that 45-degree area that's going to get epoxied onto the mount. And the last part that we're going to do is we're going to make 2 little clips on the inside of the box. And we're going to put those clips, you know, right up here and over here. And what those clips are going to do is they are going to kind of snap the circuit board down into the mount. And when that circuit board gets snapped in, it will allow us to not have to worry about gluing it down or anything. Now, Really, the way this thing is designed, you know, once I put that plug in, it's pretty much going to hold it in place. But I want to have those little snaps there to make sure that it's not going to come out at all. So right on the side and really right in the middle. And we're going to have to do this on both sides here. I'm going to create a sketch here. And so we want that to be the thickness of the actual PCB, the actual silicone wafer there. So, I mean, that probably won't focus, but there's a GPS module, you know, that is on top of a little silicone board. So I'm going to get the thickness of that silicone board, which is 1.25, pretty standard. PCB thickness there. So I'm going to draw inside here. Actually, the first thing I'm going to do is I'm going to do a, oh, what do they call that? I'm going to do a, oh, where can I do this section? Generated to cutaway. So we're basically going to cut that in half, which will allow us to get a better view of the inside here. And then we can turn off that that construction analysis at any time, right? So we can turn that on and off. But right now we've got this split where I can see the inside of the box now, and this is where I want to this is where yeah, that's right. This is where I want my my little clip to be at 1.25 millimeters above this shelf. So what I'm going to do is create a reference triangle, construction triangle, that is here to here, and it is 1.25. Ah, dang it. Where did that go? 1.25. 1.25. There we go. And it's going to stretch the whole length. So that is roughly the width of my circuit board, and I want there to be like a small little clip right there that the circuit board's going to snap down into there. So I'm going to make and what we can do here, like how big do I want that to be? Let's see. So I'm going to do another construction line right up the middle. And we'll see what I'm going to do with that here in a second. We'll draw out what is going to be our little retainer clip. And I want that to be, say, 3 millimeters thick. And let's call it, sure, 1 millimeter. No, we'll do 0.5 millimeter tall. And 1.5. 1.5. All right. So that works. And then we're going to take that area and we're going to mirror that on that line. Oh, we're going to mirror. No. Okay. And the mirror line will be right here. And we're going to hit OK. And that makes it exactly the same width on both sides. So that's awesome. That's exactly what we want. And we will go ahead and finish the sketch. And now we have these two objects here that are going to be our little clip. And we're going to extrude that out by, let's call that, oh man, this needs to be really small. We'll call that 0.25 millimeters. And what we're going to do is right here on the edges, we're going to add some fillets, and they're going to be tiny. 0.25 should make it a nice round clip, as we see there. So it's basically just going to add a little bump into the wall, and when I push that down, it's gonna, that little thing is just gonna clip in and kind of hold that that circuit board in place, as long as all the tolerances are correct. Okay. So now what we can do, because this is exactly the same on both sides, I hope, is we're going to take this whole little thing here. Uh-oh, that's not what I wanted. And we're going to split that. We're going to take this side and we're going to create a sketch here. And what we're going to do is we're going to project that object onto this sketch so we can copy that exactly. So what we want to do is project that, and as we can see on the other side, now we have a projection of that body on the other wall that we're working with. So we can create a 2-point triangle that covers that wall exactly. We can finish the sketch and we can extrude that body 0.25 and then do the same thing that we did on the other side, where we create those fillets on the top and the bottom that are also 0.25. So we're going to do fillets 0.25. All right. And that gives us another retaining clip in exactly the same spot on the other side using that project tool. And that pretty much completes our little mount that we're creating for the GPS module that's going to get mounted to the back of my little quad. So I do have to apologize. While I've been doing this, I've just kind of been talking along my process and not really paying attention to the chat. So what I want to do is kind of go back to the chat here, and if anybody has any questions or anything, I'd be happy to answer those. Why can't I move stuff around? And yeah, I'd be happy to like answer any questions that anybody has, or you know, explain any of these funky processes that I've been doing, or you know, whatever y'all got. Anybody got any questions? All right. So, not many people have been saying anything. I'm guessing that people are just watching, which is cool. Yeah, so Joseph Youngblood, Dana's RC, if you're still in here, Joseph Youngblood's recommendation of the Prusa Mark III. If you're not worried about money and you want the best printer that you can buy, that you're not going to have any issues with, you just basically, I mean, you're still going to have to calibrate it and all that stuff. But the Prusa Mark III, they're pricey. You know, they're going to run you about $700, but it's got everything. It's got all the bells and whistles. It's got the best electronics, the best stepper motors, the best power supplies, all the best stuff. And it's got a heck of a company to back them up that support their products, which you may or may not find if you're going to try to use a Chinese product. You know, as we all too well know in the RC world, some companies back their products better than others. So if you're interested in a 3D printer and money is not necessarily an object, the Prusas are not the most expensive printer out there, and they are most certainly not the cheapest, but it is the best printer for the money if you're willing to pay that much. If you're not, there's a lot of options out there, and it really depends on what you're looking for. My kind of go-to option is the Creality Ender 3 Pro, which is a heck of a printer. It's been out for a while, it's well established, and it will do stuff like this all day, no problem. So if that's something that you want to try out, and you can pick those up for, you know, between $200 to $250, depending on where you find it. If you do a little hunting on Amazon for a Creality Ender 3 Pro, you'll probably find them somewhere in that range of $200 to $250. Let's see. Oh, there is a high performance F-22? That must have just came out recently. Oh, you know, I don't mind the white background. My monitors are a high enough refresh rate that having the white background doesn't bother me. There's no like flicker, and it's higher than like fluorescent lighting. Um, so I don't worry about it. I don't mind the white, and the white offers a higher contrast level for me to see individual parts and pieces on there. Joseph Youngblood, this part is probably going to take about an hour to print. But, the nice part is that, I mean, where else are you going to find a, a mount for this little guy? That was what I was doing, was creating a mount that this little GPS module can fit down into, so I can add GPS to my quadcopter. And I just needed something that would go on the back of here, kind of like so. And this should fit the bill perfect and allow me to, to mount that on there. I'm going to epoxy that mount that you were just looking at to that flat spot right there. And it should hold very well. I'm really trying for the. I mean, there's too much hair there, man. If I was to go like completely slick, dude, I'd cannonball this baby. But I'm just doing, the short hair. But yeah, this is gonna take about an hour to print there, Joseph Youngblood. Now, what do you mean? Is this used only on The Apprentice? Sure, Shadow, I'll do it. That's awesome. I did not know that there was a 90 millimeter high performance F-22 now. The regular F-22 was awesome, and I get that Motion is trying to rid themselves of using outrunners in basically all of their jets. So I get it, it was due, and there's not a whole lot of outrunners left in their lineup of jets anymore. So that's very interesting. Now I know that that kind of shoots my plans in the foot, because my plan was, I was never disappointed with the performance of the outrunners in the F-18 or the 90 millimeter F-22. I thought that those were two of probably their better performing planes that had the outrunners in them, that really didn't need to go high performance, but they'll certainly benefit from it. So, my plan was to take the Blue Angels F-18, which has the same outrunner unit that was in the original outrunner version of the F-22, and throw that power system into an ARF Plus F-22. But now they have a high performance version of the F-22, and that makes me go, Ultra? Oh. The Ultra performance is the 8S version. So yeah, there was a Raptor, and that was 90 millimeter 6S. That was the regular one that had the outrunner. And then I think even the 8S version was still an outrunner, but it was a bigger, badder outrunner. Okay, so do they have a high performance now and an ultra performance? So they still have a high performance 6S with an in runner, and their same 8S system in their ultra performance. Got it. Well, that sucks that they're sold out. Got it, got it. So, anyway, guys, I hope that watching me draw out, little weird things in Fusion 360, little oddball mounting brackets and things like that, because I kind of did the same thing when we were um, actually, what I'll do is I'm going to go ahead and take this and go ahead and prep it to 3D print. So what we're going to do is set this up, and we'll call this GPS mount. Uh-oh. Taycan GPS mount. And save that as an STL file. We will go ahead and open up Simplify 3D, which is my slicer of choice. And that's funny. That's the camera mount that I have in my P47 that rides around on the servo. So if you guys want to take a quick look at that thing, it's got a hole right down in the center where you can run a screwdriver in there to tighten up the screw on the servo horn, and it's got, that hole runs right down through the pedestal, and then in the bottom it's also got a little relief that you can see there that the servo horn goes into, and I epoxied the servo horn into that little relief, and that left the mounting screw right there. And then you just run your screwdriver right through there, and that puts the camera right on the center point, and that's your mounting holes for the camera and the whole little bracket. So that is my FPV panning bracket that the camera's mounted to in the P47, which is pretty cool. But we're going to get rid of that guy, and we're going to put our GPS bracket in that we just created in Fusion 360. And what Simplify 3D tries to do is it tries to orient this thing on the build table. So basically what we're looking at in Simplify 3D, this is a representation of the build table of my printer, that gray area. And the orange part is the part that we were just working on in Fusion 360. Now what I'm going to do is take that, and we're going to do place surface on bed because I want that to lay out flat. I think that's going to give us the best chances of a successful print. And 40 degrees is a little tight, but I think, yeah, I don't think that's going to work. We shall see. So let's see what happens if we do prepare to print. Okay, so it does add some supports there. I think I'd probably like it better if that triangle there were solid. That way I only have to do supports on the outside. I have a feeling that I'm going to have some issues depending on what way it tries to print those. So what we can do is we can run from the top down. If we can see that all of those are going to come across. So that may work like this. That's a really short distance to bridge. So I'm gonna just leave it alone and try to print it the way it sits. And up here we can see the build time when we look in Simplify 3D, and it actually has a build time of 26 minutes. So this is going to take about 30 minutes to work. I think this is going to work, Joseph. You know, I'm sitting here kind of analyzing, you know, the tool paths, and that distance between, you know, here and here, that's only a couple of millimeters that we're talking about. This whole thing is only like 24 millimeters wide. You know, so that distance is maybe 2 to 3 millimeters that it's got a bridge right there. And you know, at least with my particular printer, print settings, calibration, all of that stuff, it does a really good job at bridging those gaps, especially when it's small like that. So I think that we're going to be in good shape, you know, just judging by that it's going straight across instead of trying to go, you know, go in line with that open area. I think that this is going to work out. What I do want is I want the supports on that 40-degree bend. I want those supports to be a little more than what I've got here. So I'm going to go back. And one of the nice things about Simplify 3D is it allows us to add custom supports. Support type normal. Build platform only. There we go. That should work a little better. I like that a little better than what we were seeing before. Because I don't want that area can't really sag down. I need it to be correct. So, you know, like that face is what's going to get epoxied onto this piece. So we're going to leave it like this. I am okay with that. And everything else should be good to go. So we are good now. We can go back to prepare to print. Ah, it's being a little bastard. Well, we will see how it does. That's all I can do. It looks like it's going to print out fine. And we'll just have to do it and see what happens. So, anyway, I don't think so, man. I don't think so. So, like this way, I think works. I think it's going to work better for everything else. You know, I can deal with just having the supports here on this angle, or I can have the whole inside of the box full of supports, which I don't really want the whole box full of supports. I'll try it both ways. I mean, I've got plenty of, yeah, it's going to be PLA shadow. Um, I don't think so, Barry. Um, and I was just looking at that. I believe that the distance from here to here, if you can see where my mouse is moving right there, that distance is only a couple of millimeters. This whole box is only 24 millimeters for some perspective. You know, so that distance from here to here is only a couple of millimeters, and my printer is absolutely capable of bridging PLA across a gap that's 2 millimeters. I mean, it could bridge across the entire 20 millimeters if I needed it to. But we're not asking it to do that. We're only asking it to bridge a 2 millimeter gap there, and I think that it's going to be fine. We shouldn't need to have any supports in there. And I'm not too worried, you know, with that little hole that cuts through there. I'm not that worried about that kind of being ugly in there. This area here, I'm a little bit concerned about. And we're just going to have to see how it goes. It may be fine because of the way that this all builds up on top of each other. It's not like we're asking it to do a real thin overhang. You know, and I do have the supports in there, but I just wish that the supports were a little better than what they're coming out as. I mean, that's what it looks like here. And then when I go to the print preview, they don't look like that anymore. I sure wish they did. But I'm just gonna roll with it and see what happens. All right. So anyway, guys, I'm gonna get out of here. Thank you guys for hanging out. The PETG would be better, and I do have some PETG, but you know, anytime I take these things out, I'm not like leaving it in the car. You know, they're in the shade. You know, it's probably about 100 degrees, and I mean, PLA does okay in 100 degrees. You know, you get up to like 130, 140, 150, it starts to deform. But it should do okay in the summer heat in the shade. You know, when I take it out and I fly, I mean, here's the thing. It only takes 30 minutes to print. So in the event that the PLA melts, because I mean, I'm just lazy and PLA is what I have loaded in there right now, and I don't want to reset up the printer. So we're just going to print it with the filament that's in there, which is why everything is orange, right? We're going to print it with everything that's in there now and just see how it does. And if it ends up, you know, melting or deforming or anything like that, I'll just make another one. No biggie. Barry, the reason that the angle is 40 degrees is, and let's go back here. If you look at this, like that is the back of the quad, and right there in that hole, that's like where the crossfire antenna mounts, and right up here is where the VTX antenna mounts, and that angle is a 40-degree angle, and I need the GPS to come straight out of the back of that thing. So the GPS module is going to sit about like that. If you can see that, it's going to sit about like that on the back of this. And that 45-degree angle that you're looking at is going to epoxy to that flat spot right there, and that flat spot's at 40 degrees. So, I mean, if I printed it at 45 degrees or even 50, I wouldn't need supports. I think it may be able to pull off 40 degrees. We'll just have to see. My printer has impressed the crap out of me with more complex stuff than this. But, at 45, I would have it kicked up by like 5 degrees. And I want that to be as flat as possible because this has a GPS and a magnetometer or electronic compass. So this has a GPS and an electronic compass in it. And I would like for that to be as flat as possible. Not that it matters. I mean, when it's flying, it's going to be all kinds of wonky angles anyway. I probably could have left it at like the 40 degrees, so when I'm flying, then it's straight up and down. But then it would be, yeah, I mean, there'd be other things to worry about. So I'm just kind of living with what I got, and we're going to see how this works. I'm going to print it, and you'll probably see on Monday how it worked out. Anyway, I'm yeah, I've done a lot of test prints on my printer, which is why I'm pretty comfortable with doing a 40-degree overhang. I want to say that I've done actually 40. Yeah, this 40 is fine. 40 is fine. It'll work. I have absolutely tested that before, and it'll work. So, I didn't remember in my head, what the angles were. So I think that I've gotten up to about 30 degrees before it starts getting really bad. And in something this small, I think that it's going to be so tightly packed, and it's going to be printing over the top of itself, because that thing, it's pretty thin. So those second layers are going to get built up pretty quick, and I've got really good cooling on the PLA, so I think I'm going to be fine if I run it at like 100% cooling. So we're going to let this thing rip. I'm going to jump off here, guys. I appreciate you coming and hanging out. And later on, if everything works out right, I will post a picture in the community posts in YouTube of this little guy inside the box and mounted onto the back of the drone. But maybe not wired up yet. But I'll at least show, what it looks like after I get the mounting bracket, epoxied to this little guy, get this on there, and get it all mounted up and looking good. So anyway, like I said, thanks for hanging out. We will see all you guys tonight at the Flight Club show. If you partake in that show, I'll be in there as usual. And we'll see y'all later. Everybody have a great day, a happy Tuesday, and we shall see you again.